Okay. Hi and welcome everybody to this FAIRPoints event on software and workflows. Today we are joined by a fantastic lineup of speakers and moderators. First speaker we have Dr. Paula Andrea Martinez, who has a background in computer science and has worked in the field of bioinformatics. She's currently the software project coordinator at the Australian Research Data Commons, ARDC, and her work supports the ARDC software program for Australia, and which contributes to leading to better research software recognition. She is also the Research Software Alliance Community Manager and has a trajectory of founding and supporting many communities. Since 2018, Paula has been working on FAIR for Research Software and was the co-chair of the FAIR for Research Software Working Group hosted by the RDA, Force 11, and Arista. And she's going to briefly talk about the FAIRpoints for FAIR for software principles and some ongoing projects. Thank you, Paula. And after that, we have Carole Goble, professor of computer science at the University of Manchester. Hi, Carole. Where she leads the team of researchers, research software engineers, and data stewards. He has spent the last 25 years working in e-science on computational workflows, reproducible science, open sharing, and knowledge and metadata management in a range of disciplines. And is one of the founders of the UK Software Sustainability Institute and has led numerous national and European e-infrastructure projects. He is currently the head of node of Elixir UK, the national node of the European Research Infrastructures for Life Sciences, Elixir, and directs digital infrastructures for the European Research Infrastructure for Industrial Biotechnology, IBISPA. Carole is also leading workflow infrastructure development for EOS cluster and natural history collection digitization. As an early pioneer of computational workflows and fair sharing of research objects, she has led the development of several widely known resources, include Taverna Workflow Management System, Workflow Hub, and My Experiment, for sharing workflows, and Fairdom Seek platform for sharing all manner of research products in bioscience. Oh God, I can go on and on. Carole, you're amazing. And she's also leading the development for rope traits, the research object traits, and for digital objects and adoption of schemas for biosciences. And Carole will be briefly talking about how we apply FAIR principles to computational workflows and highlight some of the current initiatives. So these are the main two speakers for today. We have also three moderators who are going to be leading this discussion. We have Gladys Rotish. Gladys has a background in microbiology and has practiced bioinformatics, and she has recently completed her master's in bioinformatics, and her interest lies in mathematical modeling of infectious and vector-borne diseases. And she'll be one of our moderators. We also have Gianna Jordan. Thank you, Gianna, for joining us so early from the US. And Gianna is a software engineer on the FAIR data team at Sage Bio Networks, and her work focuses on making data fair and through metadata validation and data modeling. And previously, she has worked in the field of neuroscience research engineering and integrating electrical and software systems, machine learning, and data analysis to study Parkinson's disease and aging. Diana completed her Master of Science and Bachelor of Science in Biomedical Engineering at the University of Arizona, and she's also one of our moderators. Last but not least, we have Elise Justia. Justia is a Fulbright TEA alumni and Oxford AFPOX fellow, and he's currently a data scientist at Maboa Lab Cameroon, and he joined the Maboa team to work on reliable, interpretable, and steerable projects mainly focused on disease diagnosis. His research interest spans machine learning and healthcare, and he completed his bachelor's and master's in physics at the University of Uganda in Cameroon, and um, bachelor's and master's of education at Higher Teacher Training College of Uganda, Cameroon. He's an active member of Digital Diagnostics for Smarter Health in Africa. So thank you all so much for that impressive lineup. I'm gonna stop talking now, and I'm super happy that you could all join us, and I'm really happy for everybody who made it here today. So I am just as um, a note here that we had scheduled for an hour and a half, but we will cut off at a 1 hour. And for those who will have more questions, you can add them to our notes, and we will ask the speakers to answer them asynchronously, and we will share those notes and with the questions and answers after the event. So please do add your questions in the notes section, and yeah, and with that, I will welcome our first speaker, Paula Andrea Martinez. Thank you, Paula.
Thank you, Sarah. Can you see my slides? Yeah, sound is okay? Good. Thanks for the organizers for inviting me. As you heard in my bio, I work for the Australian Research Data Commons, and my email is my name, paula.martinez@ardcedu.au. I am going to publish the slides afterwards, but you can find the DOI and the link also via the notes document. So in Australia, the way that we start with presentations is by acknowledging the country in which we live and work, and for me is the Turrbal and Yagara people, and I pay my respects to the elders past and present and emerging leaders of the land in which I live. I'm going to talk to you about FAIR, and without going into too many details, I just want everyone to know that FAIR is fundable, accessible, interoperable, and reusable. It's been published in 2016 in Data Science, and the link to the paper, it's there. Another thing that I'm going to talk about is what's the value of FAIR and the value of making inputs and outputs fair. And maybe this is just a personal opinion, but I would like everyone to set their minds into FAIR is just the first step. And the idea is to drive research impact, to improve quality of research, to improve the translation and innovation of our research outputs. Then I like to point out to this paper from 2021 from Perkel, 10 computer codes that have transformed science. And this is one of the motivations why we should focus on FAIR for research software, because computer science and code are really transforming the way we do science, and it needs to be more acknowledged and be more visible as well. You might have heard, if you come from the data background, FAIR was first put forward to the community in terms of data management. And a lot of people think that software is just another type of data, that there's not that many differences. So I like to dig into some of those features that are very specific for software that make them different than data. So software, it's a creative process. It will evolve over time. It doesn't have an end point. It can continue to improve. Another difference is that it can be executable and it doesn't stand alone. It usually has many complex dependencies that we need to be aware in order to be able to run the software. So these features have been characterized by Lamprecht et al. In 2020 in the Towards FAIR for Research software, and the URL is also there. Then with the group of the FAIR4IS that I'm going to mention in more details in the next slide, we also have a group that was working into defining what research software means in order to apply the FAIR principles to this concept. So research software is a type of software that it's created with a clear research purpose in mind or during the research process. And it includes many different forms. It could include source code, algorithms, scripts, computational workflows, executables. You might know them from different names. There's a whole discussion in that paper that I'm citing here as well, and it's linked from the FAIRPoints working group outputs. Now, a little bit of history in what things have driven the result of the FAIR for research software and what is coming next. So initially, I will just point out to some papers. In 2016, the software citation principles were presented to the community to give relevance to software as a first class output of research. So in academia, a lot of people are spending a lot of time into developing software, but they are not yet acknowledged and recognized as publication papers, for example. So the software citation principles are a good step forward. Then in 2018, we had also a community-led discussion that FAIR needs to be translated for different communities because each community has its own standards and they all have their own principles. So these communities went from neurosciences, ecology, climate sciences, they all try to adapt the FAIR principles into their domain and explain in simple words to the community how it can be applied. And that's when the first time we try to translate what is FAIR, but for software. So you can see also the link there. Then the paper in 2019 that I just cited before from Lamprecht et al. Was published in Towards FAIR Principles for Research Software. So this was a very small group of people who continuously in the last 5 years before 2019 have been doing a lot of research into research software and how the FAIR principles can be applied. So they got together and redefined them. But we were acknowledging that a small number of people cannot define the principles, that we wanted community input. And that's when we set up the case for a new group, and we formed this group, the FAIR for Research Software Group, via 3 international organizations, the RDA, RISA, and Force 11. And during 2 or 3 years, we worked together developing different papers, asking the community for feedback, collecting what they think it needs to be included, and giving a lot of examples. And at the end, in 2022, we published the first version of the FAIR for Research Software Principles, and also a paper that highlighted some organizations internationally that want to adopt the FAIR principles. So here, there's many papers that you can read in the future. And now I'm just going to go into some of the details of that work. So the FAIR for research software principles are a step forward on the path of recognizing software outputs in academia and giving it the relevance that it needs as a first-class output of research. But the impact of this is to produce better research. That's something you can read from Dan Katz et al., taking a fresh look of the FAIR for research software principles, and the link is there. It's also another output from the working group. So for anyone who is interested in the principles, I recommend reading this article. So it's one of the main outputs from the group. It's from the RDA. It's listed in Zenodo, and it lists 17 principles that are translated from the FAIR guiding principles for research data. I want to emphasize what considerations were taken when we defined the principles. So the intent is the same as the guiding principles. They are a starting point for the group and for all the discussions. Then FAIR principles are aspirational, not binary. So you can always improve how fair your product or your output is. The third consideration is that software encompasses many forms, like I've cited during the concept, but the most useful form and the easiest one to apply the FAIR principles for research software will be source code. So something that not only people can read, but also machines can action. And the fourth consideration is that there's many best practices in developing software that software engineering has developed through the years, and they are relevant and they have informed the principles, but they are not part of the principles, so they are best addressed separately. So when you have you need best practices, please follow those in your domain. And here are some examples of how FAIR can become increasingly accessible and findable. So at the beginning, if there's no access to software, then there's definitely no access or findability. Then if you have individual agreements, for example, it's only on your computer, if it's only on your private repository and nobody else can see it and they have to ask for permission to have it, then there's an increment, but still it's a difficult path to attain the software. And then it could be downloadable on an online location, for example, a personal group or a website group or a group website where people can find, if they know where to locate this website, they could find your software. Or even like it was before, maybe FTP servers are available to download this software. But going forward and improving this accessibility and findability, there are many publicly accessible code development repositories. So there might be here a few listed: Bitbucket, GitHub, GitLab, or even generic registries like Zenodo and Figshare that will give you an identifier, that will give you a citation, that will give you version control and other features that make your software even more fair. And then I think the step that's going more towards FAIR and still going with that mindset that it's not a binary, it's not that this is the end, it's always an improvement. There are many registries that are specific for a domain. So people in ecology might find some domains more useful than Zenodo, for example, or people that are working with specific languages, they might use CRAN or PyPy, and etc. And I want to highlight here the Netherlands eScience Center have made available a community curated list of research software repositories that you're welcome to have a look at. So from a distinction of the FAIR4S principles, many of them are very similar to the data one. So I'm just highlighting here the differences. We have added F1.1 and F1.2 that are very relevant to the granularity and the different versions that software has. And this goes to how software, it's different than data because it has components and because it evolves over time. And it's important to be able to identify which version people are citing and which version is better to reuse. And then in the accessibility, we added the definition that accessibility in terms of research software is to be able to retrieve the software by using standardized communication protocols. So sending an email might be standard, but it's not machine actionable. So then try to have it available for human and for machines as well. Then moving forward to increasingly interoperable and reusable. I want to go to the second road here that says the FAIR principles are dependent upon community standards, formats, and ontologies. So hence there are many examples from different specific communities, especially in these two parts of the principles, interoperable and reusable. There's a lot of community guidance that might vary between them. So please follow your community. And just I put some questions here to help you navigate how you can become increasingly fair in this too. So are the processes only available if manual steps are required? So if you need to rerun this software and make it communicate with other software or other outputs, do you need to do a lot of manual steps? The next one is, are clear provenance for inputs and outputs available? So does it mean that can you find what are the required inputs? Are you able to clearly know what are the outputs that are coming out of this software? Are they citable? Do they have persistent identifiers they can help recognize? And I'm going to show what principle is pointing to this. And then the third question is, are machine actionable exchanges of data to read and write outputs enabled? So this is very similar. Does it involve a lot of manual steps, or machines actually know where to find the software, how to find the dependencies, how to install dependencies, and how those dependencies are working together? And then the fourth question is about reusability, in the concept that research software is reusable if it accomplishes all of these other things, that it can be understood, it can be modified, it can be built upon or incorporated into other software. So the principles that address those questions are the concept of interoperability is to be enabled by application programming interfaces or APIs, and that software reads, writes, and exchanges data in a way that meets domain relevant community standards. And then the reusability that I just read from the slide before, I want to highlight R1 and R2. R1 is given a clear software license, which are different than data licenses. And an open license is preferred for increasing reusability. In R2, there are software, the software references are qualified and described. So this means that they will have attributes that can identify them. So they will have their own PIDs, they will link to the right version, and not only for other parts of software, but also the additional objects that it needs to run. For example, the data or the platform or the instrument the data has been uptaken from, and so on. Okay, with that, I am summarizing what the differences are from the FAIR for Research software principles, and just going towards the end of my presentation, I'd like to invite you to 2 events. So the first one is happening in 2 days. If you haven't registered yet, it's on the 23rd, 2 hours before the start of this meeting, on your own time. It's organized by RDA. It's called Collaborations Workshop, and the FAIRification is presenting, as well as the Software Source Code Interest Group, which is part of this work. And then in the future, if you cannot attend this short one this week, on the 24th of March, co-located to the RDA plenary, it's a research software workshop that aims to contribute guidelines, metrics, archive references, and describe how to cite research software. It's a public event. You can join in person or online, and that's where more of the EOS groups are going to be working. So I am not involved in those groups, but I recommend you say and participate in this workshop as well. Okay, that's all for me. Thanks for your attention. Please contact me if you have any questions, and I'll be here for the Q&A.
Thank you so much, Paula. Thank you. With that, please welcome Carole for the next presentation.
Yes, hello. Let me just share my screen. Hopefully you can see that. Can you see that?
We can see it in the
Yep.
presenter. Now, yeah.
Okay, so first of all, thank you very much, Paula, for that great introduction. I also have to apologize. I'm really sick. So I've got out of bed to do this, and then I'm going back to bed. So I don't know if I'm going to hold up very well, but Johan and Michael are on the call as well, and they're going to help me. So thank you, Johan and Michael. Okay, so I'm going to talk about FAIR computational workflows. And so here's the thing. What are workflows? And I'm just trying to try and move so I can see my own slides. So workflows are a special kind of software. So they are really driven around the driver towards data-intensive science, where we're preparing, analyzing, sharing increasing volumes of data. And we often come across this multi-step processing, where we want to coordinate and chain together multiple codes. We have a data flow moving between those codes, between those steps, and we need to handle the data and processing dependencies of these multiple step processes. And we also may use this for being able to, for example, coordinate job scheduling over computing infrastructure. So these kind of workflows appear as data pipelines for data cleaning and data analytics and data preparation, data collection, as sort of simulation pipelines or simulation flows, where you have multiple times that you operate the workflow in order to compare different simulations. AI or ML pipelines are typically also workflows, task scheduling, and so on. So we see this quite a lot, and we see them a lot in biology, which is where chiefly I work, but we see them in biodiversity, particle physics, elsewhere. So workflows are this special kind of software, but they have two things I think that are important from the point of view of FAIR. The first is they have this precise specification of the control and data flow of the steps, usually expressed in some sort of language. Now, that language might be quite visual, it might be a graphical language, or it might not be, but it's usually some way of being able to say one step after another. And then they have an execution platform or some sort of engine that actually does all the heavy lifting of coordinating the control flow, maintaining the data flow, accessing the computational infrastructure, handling all of the data wrangling, and doing dependency handling. And the second thing that they have is they're really driven around the notion of composition, so that you can have these steps, and these steps might be codes, there might be command line codes or tools, there might be containers, they might be other workflows, and they may even be in different languages or platforms. So there's this notion of composition, and that gives it inherently this notion of dependency, which of course affects FAIR, because if you have a FAIR workflow, that also depends upon the FAIR steps within that workflow. The workflows, we have a very broad church of workflows, and we kind of consider workflows in sort of three different areas, if you like. There's scripting, which many of you will have all used, R and Python scripting and so on. There's interactive electronic lab notebooks, or research notebooks like Jupyter notebooks, which are in some way a form of multi-step execution, although not strictly speaking controlled flow when you get down to the details. But there's also an entire world of workflow management systems and execution platforms. And this currently stands, I believe, at something around 324 of these that are currently available in the community, that are specialized in order to be able to take some sort of abstract description and then be able to operate an engine to execute them over the computational infrastructure and over the tools. So where does that mean FAIR fits? Okay, so FAIR, I've kind of divided up into four areas. FAIR fits clearly in the software, because there's this workflow management system, and there's the tools and codes that you're executing, and that's FAIR software of the kind that Paula just mentioned. But also in workflows, we have this specification which describes the inputs, outputs, and the parameters, and that's almost like a method description. So one can almost apply the FAIR data principles to that, because it's kind of a description of what you expect to do, and the FAIR software will actually then execute. Another thing about workflows is they're very tied to their data. So they're operating the data instruments effectively. So being able to represent the data that goes along with the workflow is important. They're designed specifically for data. And that includes the recording of the execution that you did as a log. And so for these, that's kind of fair data experience as well. And then we have lots of services that support the workflow environment. For example, test engines or checker workflows to see that you're getting the same benchmarking the workflows in order to see, are you getting the same results as you would expect? So there's a kind of bit of a galaxy here, or a sea of fairness operating in the workflow world. So how do you go about finding and citing workflows? Well, there's community repositories, there's a lot, specifically around certain infrastructures or certain kinds of workflow systems, like SnakeMake workflow catalog or the NF Core catalogs. There's specific community platforms. So for example, Galaxy, which is a very popular workflow system in the life sciences community that has workflows in its instances. So you have an instance and the workflows are there within the instance. Of course, GitHub repositories, just like we would normally have software. And you find them also deposited as data repositories as these encapsulated expressions, as well of the workflow description, as well as perhaps even packaged together. You will find them as through Google, and you also find them in publications. And in fact, the notion of publishing pipelines is becoming an interesting question. Some very modern journals like GigaScience or F1000, sort of some of the leading ones, are now thinking about how do we publish pipelines? And there's other journals coming along which particularly drive this notion of publishing a pipeline. And that asks the question, how do we peer review workflows? And that's an interesting question that I'm not sure I know the answer to. So going back to how do we find workflows, another way is to register them and to use registries. And that has really great advantages because then you have a centralized place. At the moment, it's very fragmented. So if you had a centralized place where you could, a one-stop shop, as it were, which hooked into those Git repos of different forms, you would then be able to find workflows from different communities, from different systems, and from different communities of practice. And I particularly want something called Workflow Hub with other colleagues, some of whom are on the call. For example, Johan from Australian Biocommons. And this has been built out of the EOSC Life project, which is part of the European Open Science Cloud work. So the Workflow Hub allows you to register workflows and organize them into collections, handle versions and make them citable, integrate with other services. And using a registry gets you a very long way to FAIR, actually, because you get a unique identifier that's persistent. You can retrieve the workflow by its identifier. You have some rich metadata that you're associated with the workflow. And you get things like licensing and indexing and searchability. So these are all the good things of fairness that Paula was talking about. We also mentioned the importance of metadata, because FAIR means standardized machine actionable metadata. That's what the FAIR is really all about. And that means we want to be able to support, we need to have some way of being able to describe certain things around our workflows. And we want our registries, services associated with workflows, and the workflow management systems themselves to be able to move towards compliance to this rich metadata. So one thing we might want is a way of describing workflows independent of their platform, because we have all these different languages. Another is to have common metadata about the workflow, about the tools in the workflows and the parameters, how you set them. And a third thing would be a way of being able to package together the workflows and the metadata and all these companion data objects and logs that I mentioned were important when you're talking about a workflow. And we've worked on all of these things, and I'll go into who is we shortly. So there's Common Workflow Language, and Michael Crusoe is on the call, and he leads Common Workflow Language, as well as Woodle, which is another similar sort of effort. We use schema.org to describe what do we mean by a workflow, things like citation, file format, so you can cite workflows. And we package workflows up using something called RO crates, which is a form of FAIR digital object. We also need to then access and retrieve those workflows and use them. And here, I mean, obviously, if you found something in the workflow registry, you could go to the GitHub where that workflow might be, or the instance where that workflow might be, if it's operating on a cloud instance, and that's where you would want to go to execute it. But you might also want to be able to port it, and you might want to also move it around a whole bunch of other services. And particularly in our life science world, we have two big activities in this area. The first is a whole bunch of APIs in order to be able to support workflow execution and workflow discovery. So, for example, the Workflow Hub supports the Tool Registry Service API, which means if you find a workflow, say that's a Galaxy workflow in Workflow Hub, you can launch it in another Galaxy instance, and vice versa. In the Galaxy instance, you can search for workflows in the Workflow Hub, because they both implement this API to be able to look into one another's resources. And then there's other exercises like the Sapiro WES or Workflow Execution Service, which if you give it a workflow, it will execute that workflow regardless of what the workflow language is. So we get some sort of sense of platform independence. And then the second thing is that we're packaging up these workflows and all their files and all the links to their files in order to be able to move them around other services. And for that, we use FAIR Digital Objects, which is associated with the FAIR Digital Object community. Of course, not all workflows are portable. So, you can't necessarily port, for example, HPC simulations. They often have to run in the instance at the facility. I briefly show here another alternative mechanism. This is DocStore, which is a much more orientated around Docker. And here, workflows in Nextflow and Galaxy, which are common workflow languages, this is tied to various different cloud instances. So if you look up a workflow in DocStore, you can launch it on one of these cloud instances that are closely associated with this kind of app store, if you will, which is a different kind of approach to the Workflow Hub. Just to talk a little bit about things like interoperability. And so there's two large ways of thinking about interoperability and reusability. One is to curate libraries of workflows and to produce kind of canonical workflow blocks, if you will, that you can put together that are validated. And so communities are doing this. So, for example, BioBB, which comes from molecular simulations, this is what they're doing. They produce lots of little workflows that they carefully maintain that you can then put together into bigger workflows. NF Core is a community effort, again, to curate pipelines. And then a second thing that you could do around interoperability is this kind of platform independent workflow execution languages that I already mentioned. Because workflows also, you ideally would want them to work, we also have a set of services that people are developing around testing and benchmarking, not just the workflows, but the code dependencies that they depend on as well. So things like Life Monitor or OpenEbench are tools that do this. There are plenty of others. And there are also best practices around how to make a software tool workflow ready. So what do you have to do in order to be able to have best practice so that your workflow tool, your software tool could be incorporated into the workflow. I put a link to some papers there, because of course your workflow is only as good as the steps within it. Finally, and kind of another piece is your workflows are basically data instruments, and data will exist outside the execution system once you've completed running your workflows. So what are those actually producing FAIR data? So I talked previously about the workflows themselves as FAIR, but this is the workflows as instruments of FAIR data. So the data products coming out of a workflow should have persistent identifiers, or have standardized metadata, or do they have provenance, and are they licensed? So this is kind of emerging idea of a FAIR data unit test that sort of tests the fairness of the workflows from the point of view of the fairness of the data that comes out of the workflows. So who's doing all of this? Well, there's very many communities from different disciplines and platforms, because the way to really get this going is to embed it in the platforms. So so Paula was talking about software in general. Here we're talking about a community that manages workflow platforms of different kinds. So it's actually a tangible community that one can engage with. And because of that, you can actually identify, well, what are the major workflow systems or platforms that people use? And if we can build in fairness into those platforms, then we're not really forcing users of those workflows or developers of those workflows to have to learn about fairness, because the fairness comes with the platform. So that's the kind of way that we're driving it, because we have a subset of software that we can operate in. So we have communities, we have registries, we have various different projects, and we do have forums. In particular, we have the Workflow Community Initiative, which I think is doing more than most. I mean, we aren't really doing workflows, fair workflows in RDA or RESA, other than the fact that the workflow management systems themselves are software, of course. And we are associated with the Fair Digital Objects Forum because of this notion of using digital objects, these RO crates, to package together the components of workflows. So if you wanted too long didn't read or didn't listen how to make your workflows fair, the first thing I would say is register them, because if you registered them in a registry, then you'll get a heck of a long way to being fair. And then it's basically doing some basic stuff, documenting the inputs and outputs, using standard data formats and identifiers, and using stable and licensed codes as the steps. Think about modularization and unit testing, and use a workflow management system that actually does a lot of the heavy lifting for you, and join a community of practice associated with those workflow systems. And that will help a lot more with your fair practices. And this is just a thank you to many people, and some of the people who are on this call as well, who've helped this.
Thank you so much, Carole. Thank you, Paula. And Carole, we're very keen to get you to rest as soon as possible. So we're gonna. Oh gosh. We're very, very grateful for you joining us. Get well soon. So what we're gonna do is we're gonna have some quick questions and from our moderators. And please, everybody who has a question, please add it to the document. We're gonna ask our presenters to add some answers after this call and share it with you. So, okay, first question from Gianna, please go ahead.
Hi. So my question is, how do you see the role that software plays in the discoverability of data and research topics and workflows changing in the future as technology advances? As like we get more things like ChatGPT that are like more AI and machine learning for suggestion and communicating. How do you see that impacting how we like discover data sets, how we discover workflows and research topics?
Do you want to go first, Paula?
Okay, thanks for the question. I'm gonna make a relationship with databases. You can only find what's exists in a database and nothing else. So I think the relationship with software is like you can only find it if there's enough descriptive metadata to find it. If it doesn't have that, it doesn't matter if it's really public, if it has a PID. So like you need that descriptive metadata and then all the links to that link from different sources in order to be able to make it discoverable.
I think things like ChatGPT are very interesting. I mean, who uses ChatGPT here? Yeah, because it's really useful for general stuff, but actually it's not very useful for anything specific, because it's kind of works just at the generic kind of level. Now I think it will get better. And I see, and I can see really that as things improve, as it gets more more recent learnings associated with it, as we better describe things so that ChatGPT can get it and things like it can get its teeth into some descriptions, which is what Paula was saying, then I can see it as a very effective tool for discovering things. I think, but when it comes down to it, you need the descriptions. Otherwise, there's nothing to be able to really get your teeth into. So I think that's what's really interesting. I also would say what's been quite interesting is the Google data set search, which has been a challenge for Google to do, because they've discovered so many people are so bad at describing their data. So it's actually quite difficult to standardize, and they've ended up using very few terms in order to be able to do data set search. And I wonder if that's going to be continue to be a challenge with software and with workflows. So perhaps the question should be really, how can ChatGPT or other systems or AI systems improve the acquisition of metadata rather than do search? And so for me, the big issue is metadata, getting metadata out. Metadata for registering, metadata for understanding the inputs and outputs of steps in workflows or software. People just don't do it themselves. You have to automate it. You have to somehow get that out of the systems with as a side effect, as something that's just by stealth. And I'm interested in all aspects that can be able to support metadata acquisition. And I think AI techniques will be really helpful there in order to be able to, and text mining techniques and other similar techniques can be very helpful. I don't know if anybody else has some good responses.
Thank you both for your answers.
Does anybody else have a better answer?
Yeah, please feel free to unmute yourself. All right. So next question we have from Elisa. Please feel free to. Oh, you're muted. Sorry.
Hello, good morning. My question is about how do we know that research softwares and workflows are both intuitive and functional?
So this is to do with quality of the workflow, you mean, or the software? Is that right, Elsie?
Yes.
Yeah, that's interesting, because the one thing that that FAIR doesn't do is worry about quality. It's completely orthogonal to quality and the functionality. Actually, like, does it really do the job that you wanted it to do? FAIR is about finding it and being able to access it and being able to reuse it, but it might be rubbish. And so this is the difficulty. It's also true in data, by the way, that FAIR data has got nothing to say about the quality of the data. So I think that then comes to the issue to do with software practice and being able to the quality, validate. How do we peer review software? How do we peer review workflows? How do we improve the quality of workflows and software within the community? And how do we actually document it? Is there testing suites associated with it? There are sort of metrics for things like the chaos metrics that tell us about how active software is. But the actual metrics for quality is actually much harder. So people say, well, how many GitHub issues are there? That's not a measure of quality. That's a measure of activity. If there are no GitHub issues, that usually means the software is so bad nobody wants to use it. So the more the more issues that you have, the more likely the software is actually being used, and therefore it's more likely to be a better quality. So it's very difficult to be able to judge. So I think that's a complicated question that you're actually posing, which FAIR sidesteps, because it doesn't really speak to that. But it does speak to the fact that how do we actually document and improve the quality of our research software? And that is largely what the research software engineering community is trying to do. So have you heard of RSEs, Elsie? The Research Software Engineering and Society of Research Software Engineering. I'll put a link in the chat. That is trying to address those kind of issues. But Paula might have a more nuanced answer.
I think you've covered most of it, Carole. I just wanted to say that if you are a user, I think a measure of how good is a software working, it's finding documentation. If it doesn't have, then you are not able to reuse it because you don't know how it will work. And just adding to what Carole said, good documentation will have testing, will have examples, will have test data sets that will help you with the reuse, and then you can verify the quality and if it's working or not, as it says it should be.
To be honest, with workflow systems, the workflow systems that, people, which ones do they pick? People pick the ones that is suited to their particular problem, because there's all different kinds of ways that the systems operate. Are you dealing with something that's to do with task scheduling, or are you trying to stitch together remote third-party services or containers? What kind of data it is that you're processing? But the most important one is, do your friends use it? And that's the biggest one. Is there a community that I can join? And then you get this kind of critical mass. And because there's critical mass, there's much more training, there's much more best practices, there's much more a kind of quality assurance, because people are looking at one another's workflows. And so you get better quality activity around it. So it's a kind of self-fulfilling prophecy in a way. So that's what happens in the workflow world, at least.
Thank you very much for that answer. And we have one more question from Gladys, our third moderator.
Okay, so my question is about the workflow registry. So if you want to register a workflow in the registry, does it have conditions like maybe the workflow should have been published in somewhere like GitHub, or you can just wish to register the workflow, but now then you may have your workflow not published anywhere else?
So I could speak to about my workflow registry, the workflow hub. Your workflow can be in GitHub, or you can upload your workflow directly as a set of files, because we take Jupyter notebooks, and we also take our scripts and things like this, and we can make objects out of them within the platform. But we do ask for some documentation. What we do is more to do with reporting what you have, and then we let the community decide what to do with it. So that means that we don't force you to have certain extensive metadata, but we expose what you have got. So if you haven't got much, you don't get used. So it's a bit of a way of being able to sort of sidestep the quality question, if you will. We don't force you to have something in GitHub or Git, but it's a lot easier if you do. And we have tooling in order to be able to support that, that manages, for example, the versions that you may be changing, so that those versions then get reflected on the registry. And so you can keep things up to date. Otherwise, if you're just uploading a bunch of files, you're kind of fixing it in time. This is what it was at that particular time. Do you see what I mean?
Oh, yes, I do. Thanks.
Okay. But I think what we're trying to do at the moment is just get the idea that you should register these things, and then to improve the metadata. And we're also working with workflow management systems like Galaxy and Nextflow and SnakeMake in order to be able to extract out metadata from those so that that gets registered automatically when you register a workflow, so you don't have to do very much work. That's the idea. But Johan, who is on the call, who leads all this for the Australian Biocommons, might be able to have some comments. Because my voice is going, Johan.
Yeah, I think you've covered a lot of it so far already, Carole. I mean, most of my experience is with the Workflow Hub, but the other major registry out there is DocStore. For Workflow Hub, the barrier to use is actually quite low to encourage people to add things there, and it's actually quite straightforward to do so. But yeah, like Carole said, the more metadata you add, the more useful your entry becomes, the more findable it becomes, and it leads to all those other things like the trust discussion that was just had before. So the more documentation you have, you know, the more open the development of your workflow, all of those things that they build into that sense of trust that someone viewing your workflow for the first time has.
Thank you so much. Carole, are you okay if we take one question from the audience? Is that okay?
Yeah. I've got helpers.
Okay. So I'm opening the floor for one question from the audience, and the rest of the questions please add in to the document. Anyone wants to voice their question? No?
There's nobody who wants to ask us a question.
There are tons of questions in the document, but I think people are very worried about your health.
No, it's all right. It's okay. I'm not going to die. It's fine. And I've got friends on the call who can help out. So feel free to ask a question. Maybe when we can look at some of the other questions, there were some quite challenging questions, actually.
Yeah,
the
maybe
list.
one of our moderators wants to lift a question. Elise, did you want to?
Yeah.
Okay, go ahead.
Yes, I wanted to ask, what are the challenges and benefits of replicating workflows, maybe in terms of infrastructure?
Of replicating workflows? You mean actually reusing other people's workflows, or
yeah.
Well, okay, so it's actually they're incredibly they're actually very rich notions of method, right? So if you've actually, somebody's put a lot of work into the design of a workflow, and it's like a design of a method, like a protocol. So by reusing them, you're really using quite a lot of extensive know-how. An example of that is let's say there's the variant calling, or the workflows that were developed for COVID by Galaxy. Those were used extensively in order to be able to constantly revisit the data sources, in order to be able to give new information about variants. And those workflows were then adopted by different countries in order to be able to do their variant surveillance. Now, people built those together. They were validated. They were very carefully kind of QA'd. And then other communities were able to install them and use them within their own infrastructures. So that's kind of one of the big benefits of workflows, is you can reuse them. You'll be able to benefit from the knowledge that other people have, but also you'll be able to benefit from comparisons to what other people have done as well, because you're using the same sort of workflows. Or if you vary the workflow a bit, at least you can explicitly see where you varied the workflow when you're doing a comparison of the results. So so being able to share workflows and to reuse them And it's actually a powerful way of improving productivity, and I think improving the kind of sharing of knowledge within science. But it's an interesting question. And I think you'll find that, there are many workflows that people just are their own personal workflows that they use for their own productivity. But it depends where you are in the food chain, I think. So there are workflow systems or workflows that are developed by a particular, sort of almost like a facility that then are used by users, but they didn't actually write the workflows, right the way through to people who use the workflows are basically their mechanism of doing their research, and they're doing the hands-on development of those workflows, and they may not be reusable by others. So it's a spectrum. I've got some slides on this, but I didn't put them into the slide deck. I'm drawing the slide in front of you, right? And that's true of workflow systems as well. I hope that was understandable.
Thank you so much, Carole. I think it's really up time to wrap up, and I want to thank our speakers and the moderators and everybody who joined us and stayed with us so far. So folks, again, please feel free to add your questions to the document. And here are some links and notes for how to stay in touch with us. So you have the speakers bios, you have the notes, you have our website, and I hope to see you in our next and upcoming events. So please sign up for the event series. And again, thank you so much, Carole, and I hope you get some rest. Paula, I'm so glad that you could join us. I know it's really late over there, so thank you so much for that. And for our moderators, it's wonderful having you, and thank you all so much. Have a wonderful time. I'm finished.